Well over 90% of bricks made in the United Kingdom are made of some type of clay. We have a wide range of clays for brick making, producing great variety of colours, textures, strengths and durabilities. Brick has been a staple of British building for many centuries. The Romans first introduced the material to us when their legions colonised our island nearly 2,000 years ago. Very few of their buildings remain intact, but their bricks have survived, and we can see them reused centuries later in Anglo-Saxon and Norman buildings. St Albans Cathedral is built of Roman bricks, taken from the ruins of the nearby town of Verulamium, so they were used nearly 1,000 years after they were first made. They are large, generally square and thin, perhaps more akin to large tiles, quite unlike bricks today. Brickmaking was reintroduced into England from Northern Europe in the early 13th century. These grand houses were built at a time when brick was new and a very prestigious material. These bricks are small and oblong, the key thing being that they can be picked up in one hand and with a trowel of mortar in the other, laid to form brickwork. They were handmade, at first by itinerant brickmakers from clay on the building site. Brick was quickly accepted because of its great versatility and durability. It passed from being a material of the privileged to become commonplace. Countless millions of bricks like these were used in the following centuries. Until about 1800, bricks were handmade, not only the moulding, but all the other activities too. Digging the raw material, barrowing it from the clay pit, preparing and mixing it with water, loading and drawing kilns, all were done by hand, simply because no suitable machinery existed. With the development of industrialisation, mechanisation was applied to brickmaking. The 19th century saw many developments in machinery for excavating and preparing the clay, and also for forming bricks by moulding, pressing and extrusion. Modern brickmaking is dominated by mechanisation, but some of the early methods survive. Either way, the process is common. Extraction or winning, preparation, forming, drying and firing, sorting and dispatch. We're now at a works in the southeast of England to look at a product which is typical of this region. It is the stock brick, a brick made from soft mud clays to which has been added 10% fuel. The brick is then moulded and then fired traditionally in a structure such as the one I'm standing on now. It's known as a clamp. The clay for this type of brick is normally quite young in geological terms and relatively near the surface. Here, minor variations in the basic clay require it to be dug from various points for blending as it is fed into the works. At some other works, variation is dealt with by stockpiling the clays in layers. Stockpiles are often left to weather or sour for 6 months or more so that rain can wash out any impurities. In stock brick making, fuel is added to the clay. In this case, it's ground coke. The clay and fuel are thoroughly mixed and ground, and water is added to achieve the right consistency for moulding. The bricks are formed here by a machine which presses the clay into moulds. The bricks are turned out and placed in racking on trolleys, which are then taken to drying chambers for about 3 days. Freshly moulded bricks are too soft to handle and too wet to fire without severe risk of cracking. Traditionally, drying was done in the open air in sheltered hacks, a method requiring warm weather. A clamp for firing bricks is started by laying a base layer of coke about 450 millimeters deep. The green unfired bricks are stacked in layers on top of this base, and the whole stack is encased with a couple of layers of previously fired bricks. This conserves the heat and protects the exterior of the stack. Between 1 million and 2 million bricks are built or set in the clamp. The base layer of coke is then set alight, firing all the bricks in the clamp. The coke previously added to the clay aids complete firing. Clamps are not permanent structures, the roofs are merely protection from the rain. The whole process of setting the clamp, firing it and then demolishing it takes about 12 weeks. In different parts of the clamp, variations in temperatures and air supply affect the colour of individual bricks. The bricks are sorted according to their colour. In this particular part of the yard, we're looking at some special shapes that have been made. We've now moved to the Forest of Dean to another works. Here the soft mud process is being used, but in this case the bricks are made by hand. The clay is prepared or pugged to the right consistency for moulding, and in this case it is formed into clots using a machine. In some works, clots are cut or dragged by hand from a pile of pugged clay at the side of the brickmaker's bench. The hand moulder rolls the clot of clay in dry sand to prevent it sticking in the mould. In the base of the mould, a small raised piece deflects the clay into the corners and edges, ensuring a well-formed brick. This raised piece produces the frog, a sunken area in the top of the brick. Sand is sometimes used to give colour and texture to the surface of the brick. Bricks are formed oversized to allow for shrinkage during drying and firing. In soft mud bricks, this can be quite dramatic. Here's a simple kiln, a permanent structure for the controlled firing of bricks. This one's a Scotch kiln. It has thick walls and is open at the top. The doorway is bricked up before firing. As kilns developed, they became enclosed structures. This coal-fired downdraft kiln has a chimney to draw heat from the perimeter stoke holes through the bricks. It provides a better spread of heat than an open kiln. Here's another sort of kiln. These green bricks are being set on one of a pair of hearths in a pattern that allows heat to permeate. When the setting is complete, a movable gas-fired kiln called a moving hood slides over the bricks to fire them. A moving hood kiln serves two hearths. While one is being fired, the other is being loaded. All the bricks we have looked at so far have been made using the soft mud process. These bricks are also referred to as stocks and are perhaps most admired for their colours and textures. These long, narrow handmade bricks were made to a special size to emphasise the unusual bond pattern of the brickwork. The small black marks on these bricks are the remains of crushed fuel particles mixed with the clay to aid firing. Until the opening of the 19th century, all bricks were handmade, generally from shallow clay deposits. This was soon to change. As the Industrial Revolution gained pace during the 19th century, there were three key factors which drove manufacture forward. One was the discovery of new, deep-lying clay deposits, often found when mining coal and other minerals. Another factor was the increase in mechanization. This not only allowed the deeper clays to be extracted, but also enabled fast industrialized production. During this time, hundreds of brickmaking machines were patented. The third factor was the development of the railways, which offered cheap and fast distribution. In fact, many brickworks had their own rail links. The combination of these factors enabled bricks to become the staple material to satisfy the burgeoning demand for buildings and civil engineering structures. By the end of the Victorian period, bricks were being made throughout England and in many parts of Scotland, Wales and Ireland. Millions of bricks were used for the construction of buildings of all types. Countless millions more were used in hidden infrastructure, much of which is still in use today. So how was brickmaking transformed? We're here today at Kingsdyke Works, a works making Fletton bricks from Lower Oxfordshire clay. It's a very large works. It in fact is the largest brickworks in Europe and has a capacity of approaching 5 million bricks a week. We see behind us the multiple chambered Hoffman kilns which continuously burn to keep this brick made on a continuous process. The whole works is built in the bottom of a clay working pit to keep it down and out of the general profile on the landscape. Quite an important clay deposit, this one, because it makes a unique product, as we shall see as we look at the process. This is a shale planer. It's actually skimming the surface of the clay off the quarry face and taking it down into conveyors which will be taken into the works. The clay is particularly pure and consistent in this quarry, and so we can actually dig it, or win it as the technical term is, by this method. It's a relatively unusual machine to find in clay excavation, but in this particular deposit we can exploit its potential because the clay is so clean and consistent. The consistent quality of the clay means that it doesn't have to be blended or stockpiled before being taken into the factory. Any metallic debris is removed and the clay is ground in a series of machines to reduce the particle size to a maximum of 2 millimeters. Larger particles are returned to the grinders. The resulting coarse, semi-dry powder is then compacted into moulds by powerful presses. The large frog, which is characteristic of these bricks, is formed by the press's wedge-shaped ram, which forces the clay into the corners and edges of the mould. A surface texture may be applied to the face and ends of each brick. These bricks are being sand-faced. The bricks are then set into packs in a particular pattern so that they can be handled by forklift trucks and placed into the kiln. This is a continuous burning, multi-chamber Hoffman kiln in which each chamber is effectively an independent enclosed kiln. When a chamber is full, the entrance is temporarily bricked up with dry laid bricks and the whole surface rendered over to make it relatively airtight. Hoffman kilns are of various sizes. This is a particularly large one with 36 chambers. The fire moves clockwise from chamber to chamber around the system, each chamber warming, firing and cooling as the fire moves by. When it is cooled, each chamber is cleared of fired bricks. Unfired bricks are then set to be warmed, fired and cooled as the fire passes on its next circuit. The continuous process is closely monitored and can be speeded up or slowed down to suit production needs. The unique feature of fletton clay is that it contains fuel sufficient to burn the bricks. It is known as the clay that burns, and the multi-chamber Hoffman kiln is particularly appropriate for fletton production. The temperatures reached in this kiln will be of the order of 1,000 degrees centigrade, and it will process our bricks very well. But the bricks from which the kiln itself is made are rather special bricks, and they're refractory bricks made to withstand the intense temperature that is reached within the kiln and is processed many times over. They're put together without mortar because mortar wouldn't survive the great temperatures, so they're put together dry jointed, as it were, in these arch formations. And indeed, some of the bricks themselves have melted in the extreme temperatures reached in parts of the kiln. When the fire has passed by and the chamber has cooled, the sealed opening is broken out and the fired bricks removed, sorted and packed for dispatch. Pressed fletton bricks fired in Hoffman kilns are very economically produced and have been widely used in British building for well over 100 years. The use of presses and Hoffman kilns, however, is not unique to the fletton clay. Cattybrook Brickworks, near Bristol, supplied bricks for the Severn Tunnel in the late 19th century. Their hardness and soundness particularly impressed the engineers, and over 30 million bricks were incorporated in the tunnel. We've looked at making bricks by hand and moulding soft mud clays in a machine. We've looked at pressing bricks from semi-dry clay. We've also looked at a variety of ways in which bricks are fired. from the primitive clamp in intermittent kilns and the multi-chamber continuous burning Hoffman kiln. We're at a works now which uses two different techniques for both making and firing the bricks. The bricks are made by the extrusion and wire cutting process, and they're fired by a continuous burning tunnel kiln. In combination, these two techniques are used in the majority of brick making in the UK at the present time. In the quarry, there are two varieties of rock-like clay, one that naturally fires red and the other that naturally fires buff. Other clays are also imported to increase the variety of products. Any blending that's necessary begins in the quarry by layering the clay in stockpiles. At this works, clay is brought into the factory and left for a few days to precondition it prior to screening and grinding. This evens out subsequent shrinkage during manufacture. Manganese dioxide can be added to modify the natural burning colour of the clay. This produces greyish bricks from the buff burning clay and brown bricks from the red one. Water is added to produce a stiff plastic consistency suitable for extrusion. The flow of clay is controlled by rods in the throat of the die. These produce what will later be seen as perforations through the brick. The pattern varies according to the nature of the clay. The surface of the extruded clay, normally smooth, can be textured by devices like drag wires, rollers or sand blasters. Clay is passed to a machine where taut wires cut it into individual bricks at the rate of 7,000 an hour, enough to build a house. The bricks are then taken to dryers for about 3 days. The heat for these is recovered from the kiln. The shape of the die on the extruder can of course be changed or modified to produce special shaped bricks. These are sill bricks. A tunnel kiln, usually fired by gas, is about 100 metres long and has a firing zone in its middle section. Air supply in the firing zone can be regulated to produce special colour effects. The journey through the tunnel kiln takes about 3 days. The bricks are now ready for blending, packing and dispatch. Extrusion, wire cutting and tunnel kiln firing don't have to go together, but when combined they do offer highly automated manufacture and economic high volume production. We have seen that many techniques are used to make clay bricks in Britain today, and the products of this industry offer great variety of colour, texture and physical properties. Modern designers and builders have a wonderful choice with which they can continue the great tradition of British brickwork in the buildings and civil engineering structures they create for us today.